In today's video, we're going to look at section 6-8, roots and zeros. And realistically, roots and zeros mean the same thing, so we're looking at roots and zeros. We're looking at the same thing. Okay, so zeros, factors, and roots, let f of x equal the polynomial function. Then the following statements are equivalent. C is a zero of the polynomial function. X minus c is a factor of the polynomial f of x. C is a root or solution of the polynomial equation f of x equals 0. So in addition, if c is a real number, then c comma 0 is an intercept of the graph of f of x. So now we've thrown in zeros, factors, roots, solutions, intercepts. This is all the same thing. So the fundamental theorem of algebra, every polynomial equation with complex coordinates and degree greater than 0 has at least one root in the set of complex numbers. Okay, so there's at least one answer. That's kind of nice. So we always have some sort of answer. So let's see how we can go about this. Okay, so now we'll start off easy. Solve each equation, state the number of and types of roots. So x squared minus 8x plus 16 is equal to this. So we've done this one in the past. Let's just factor it. It becomes, if we remember, this one factors x minus 4 times x minus 4. And that's equal to 0. So solving both for 0, so we have x equals 4. Now, it actually has how many different roots? So it has one root. It has two that are one's repeated, but it's only one answer. So it's one real root, and that's all it has. Okay, so that's your answer. It's got one real root. Now let's do the next one. So the next one, we can see this is a difference of two squares. So we get x squared minus 1 times x squared plus 1. So both of these we can set equal to 0. We get x squared minus 1 equals 0. X squared plus 1 equals 0. So x squared equals 1. So we get x equals plus minus 1. Here we get x squared equals negative 1. So x is equal to plus minus I. So in this case, we actually have two real roots and two imaginary roots. Okay, so it actually has 4 roots total. Okay, so 4 total. So that's what we're looking at. Okay, so we've done this in the past. Now we're just kind of putting it all together in theorems. So now a polynomial equation of the form p of x equals 0 of degree n with complex coefficients has exactly nth roots in the set of complex numbers. So if it has a degree of 3, that means it's going to have 3 roots in the complex numbers. Remember, complex numbers are both imaginary and real. So Descartes' rule of signs. If p of x is a polynomial with real coefficients, the terms of which are arranged in descending powers of the variable, the number of positive real zeros of y equals p of x is the same as the number of changes in the sign of the coefficients of the terms, or is less than this by an even number. Okay, so and then the number of negative real zeros of y equals p of x is the same as the number of change in sign of the coefficients of the terms of p of negative x, or this is less than down by a negative number. So if it's real, it's not imaginary. If it's not real, then it's imaginary. Okay, so I'm going to go through an example, so please pay attention to this. Remember, we're looking for number of sign changes. So first, state the possible number of positive real zeros and negative real zeros and imaginary zeros. Okay, so here we go. So first, we're going to just look right away. So I'm going to start with x to the 5th minus 6x to the 4th minus 3x cubed plus 7x squared minus 8x plus 1. Okay, so here we go. We have positive to negative. That's a change. That's one change. Next we have negative to a negative, not a change. Negative to a positive, that's a second change. Positive to a negative, that is a third change. And negative to a positive, that is a fourth change. Okay? And put no here so we know. Okay? So we have 4 changes. All right, now we're going to put in negative x into this equation. So I'm going to put this out front. P of x was just the original. Now I'm going to do P of negative x. So anywhere there's an x, I'm going to put negative x. So negative x to the 5th minus 6 times negative x to the 4th minus 3 times negative x to the 3rd plus 7 times negative x squared minus 8 times negative x plus 1. So now after we simplify, we got to look at how it changes. So negative x to the 5th, when we simplify it using our exponents, we still get negative x to the 5th. The next one, minus 6 negative x to the 4th, well, negative to an even exponent, that's just positive. So it stays negative 6x to the 4th. The next one, we have a double negative, so it becomes positive 3x to the 3rd. Next one, even exponent, so it stays the same, so plus 7x squared, and then plus 8x, and then plus 1. Okay, so I'm just simplifying all my multiplication with negatives. So then, again, I'm going to look at number of sign changes. So negative to a negative, that's no, doesn't change. Negative to a positive, that's 1. Positive to a positive, no. Positive to a positive, no. Positive to a positive, no. So there's only one sign change. Okay, so now let's make out a grid. Okay, now I'm going to extend my page here. So we have number of positives. We have number of negatives. And we have number of imaginary. Okay, so now positives. This could be, remember, the number of sign changes or less by 2's. Okay, so it could be 4, it could be 2, or it could be 0. Okay, and then the number of negatives, well, there's only one sign change, and if you go down by 2, it's negative 1. You can't have negative answers. That makes negative number of answers. Makes no sense. So we could have 1, we could have 1, or we could have 1. So now there is a total of 5. It has 5 solutions in the complex plane. So we have 4 positives, 1 negative. That means if that's the case, there are 0 imaginary. If there are 2 positives and only 1 negative, that means there would have to be 2 imaginary. And if there are 0 positives and 1 negative, that means there would have to be 4 imaginary. Okay, so and if you add up across, it'll always equal 5. So that's what we're looking to do. Okay, so that is some basics of roots and zeros. We're not going to do this problem, so please ignore that one. So suppose complex conjugates theorem. Suppose a and b are real numbers with b not equal to 0. If a plus bi is a 0 of a polynomial function with real coefficients, then a minus bi is also a 0. So if you looked at the last one, the imaginaries went from 0 to 4 every single time. So it always works like that. So they give us write a polynomial function of least degree. So we're given 2 with integral coefficients. They give us 3 and 2 minus 1, or 2 minus I. So if 2 minus I is, then 2 plus I must be 1. So we can make these into 3 different factors. So we have x minus 3. We would have x minus 2 minus I. And we'd have x minus, plus, sorry, minus again, still minus, that stays minus, it's always minus, minus 2 plus I. Okay, and then what's nice is we can rearrange this a little bit inside the parentheses. So if I actually change my parentheses to x minus 2, it would become plus I here. And then this one would become x minus 2 minus I. And if we look really closely, this is actually a difference of squares. Okay? This will become a difference of squares. It's a plus minus multiplication. So we can simplify this really easy. It actually just becomes x minus 2 quantity squared minus I squared. Okay, and then we're still multiplying the x minus 3 on the outside. So now x minus 2 quantity squared, that is just x minus 4x plus 4, and then negative I squared is just negative 1, so minus a negative 1 would just be plus 1. Okay. And so I'm just simplifying. So x minus 3. So we have x minus 4x plus 5. Okay. So now we're just going to finish it off. And when we distribute, I'm going to distribute my x minus 3. Oh, I forgot my square here. Sorry about that. X squared. There we go. So I get x cubed minus 4x squared plus 5x. Then I'm going to distribute with my negative 3. I get minus 3x squared plus 12x minus 15. And now I just simplify. So x cubed, and then the squareds, we get minus 7x squared. We get the x's, so we get plus 17x, and then the last one, minus 15. And that is our polynomial of least degree that has coefficients, integral coefficients. I know it's a little cumbersome, but it takes some practice. So